I guess quick show of hands. How many people showed up to my session yesterday? Whoa! Okay, great, cool. Um, so that was basically my beginner session. This is more advanced. Don't worry for folks that didn't attend yesterday. I'll make sure that y'all at least get some of the core concepts. Okay, so during the last session, we learned how to get a basic chat loop going and having an AI actually performing automated tasks and pulling data from places like Microsoft Bing. In this session, we're going to figure out how we can take this agent and incorporate it into a larger business process, a workflow. Because yes, chatbots are fun, but what we ultimately, at least I hope y'all aspire to do, is start driving more business automation so that your own companies or maybe your own customers can be more productive using your tools. Okay. So today, what do we have? We have highly manual processes. I pulled this together probably a month ago. I had 2 insurance claims that I had to do. My bicycle was stolen, and I forgot what the other one was. Anyway, something got messed up. And this poor claims examiner literally called me every single day for 2 weeks. And as a very busy Microsoft employee, I never picked up the phone. And that is an activity that no human should have to ever do. That's something that is perfect for automation, perfect for these new LLMs to accomplish. And what we at Microsoft are privileged to have is an entire research division that does development research out in the open. And one of the most popular projects, how many people have heard of Autogen? I'm going to assume not Vinny. Perfect. Okay, that's what I expected for this crowd. So Autogen is a research project where a year ago, they asked the question, what if instead of just having a single chatbot thing, and Microsoft would call them copilots, what if we had multiple and had them work together? Similar to how we as humans, we come together as teams to accomplish more than just a single person. And lo and behold, from their research, they were able to prove that teams of agents were able to accomplish more. And if we kind of fast forward to today, they've learned that if you actually model the orchestration, the collaboration between these agents as an actual business process, instead of just like throwing them into a group chat and kind of hoping for the best, you get better results. And so what we have done is we've taken the core concepts that y'all learned about yesterday, plugins, planners, personas. For those of you that weren't here yesterday, plugins are the skills, the capabilities that your AI can do. Planning is the ability to reason and think about those skills to accomplish a task. And the persona is, who am I? Am I a PM agent? Am I a coder? Am I customer support? And what you can do with these 3 is you can create unique collections of them. So if you're a customer support agent, you'll have a customer support agent persona. You are a customer support person. Be super friendly and nice and try to get discounts to keep the person to stay. And then for plugins, you might have a retrieve available discounts. You might get, I don't know, send order or send thank you or whatever it might be to make sure that that customer is supported. That's going to be very different than a developer agent who's going to be given plugins to write code or check things into GitHub, right? And because they're different, they'll have, just like us, different skills and backgrounds because of what we told them their life story was. And if you can put them together, they can accomplish more. There was a really great question yesterday. I have all of these APIs. I have hundreds of APIs. If you give them all to a single agent, its brain, its artificial brain will explode and it'll just like start making up stuff. But if you can carve it up into specialized agents, it's going to be more successful. And so what we have done in Microsoft is try to figure out how is the easiest, best way of stitching these agents together. And what we have landed on is something called processes. Other frameworks, I don't know if any of you are familiar with a LangGraph or LangChain. they have this concept of like building these graphs. This is very, very similar, except for all of you .NET devs, C# devs, this is something that you can actually use in your enterprise applications. Okay, so what is a process? I'll try to go through this slide pretty quick so we can look at real code. It's exactly what you think it is. It's a collection of steps. Wow, shocker. So this is what it looks like. It's powered by Dapper. Show of hands, how many of y'all use Dapper today? Maybe? Okay, a handful of folks. Okay, so for folks that aren't familiar with Dapper, it is this event-based framework that you can run in the cloud that allows you to have very highly distributed systems. Because what we believe in the future is you're going to have hundreds or thousands of these agents that are accomplishing all sorts of jobs. And to have them in a scalable way, you're going to have some sort of framework like Dapper kind of orchestrating all these things together. What we've done is layered on top of Dapper some helper convenience methods for all of you .NET devs to very easily wire together these steps, or what I like to call agents. Okay. We'll see what they look like in a bit, but they're stateful, reusable, all those wonderful good things. Okay. So let's look at some examples of processes. So everyone probably is familiar with like the standard account opening scenario. So a customer comes in and says, I want to be one of your customers. You have to ingest them, right? And today, that's probably a highly manual process. Someone has to get on a phone or they receive an email. You have to, hey, what's their particular rating? Do we reject them? Like they're not good customer for us? Do we approve them? Do we check for things like fraud detection? And kind of the process just keeps going on and on and on. And what we believe in Microsoft is not all the steps. You don't want all the steps to be automated because you still need humans to do things like approvals or like determining customer credit rating. Like that's something either an API should be able to do, and actually doing some of the mail service, that's maybe a human job. But many of these things can start being automated by these large language models. Similarly, this is probably something that you're all familiar with as devs, which is ticket processing. Y'all get these tickets. Y'all then have to triage it. Y'all probably have daily meetings going, oh, what's the severity? Like, which team actually needs to look at this? Some poor human has to read that ticket every single time. That's a perfect task for an LLM to just quickly scan it and decide which team should have it. Like, is it something high priority or not? And maybe a human, instead of every day looking at it, once a week, are like, oh, let's double check what the agent did, right? And if you model this as a workflow, you can do more than just triage it. Once you send it to the other teams, maybe they have their own process that they want to apply to these tickets to potentially even automatically resolve them. And then everyone loves ordering pizza scenarios, so we have one of those, but we're just going to skip that. Okay. So let's go ahead and build our first process. And our first process is going to have 0 AI in it, just so that we can start understanding some of the core concepts of semantic kernel's process framework. And I guess while we're doing this, if you are interested in kind of trying this out in the future, if you go to, and I'll repeat this at the end, if you go to semantic kernel, and go to our .NET library and samples, and we have this whole thing on processes. Look at those beautiful NuGet packages. And it kind of walks through increasingly more complex scenarios. What we're going to be doing today is really just step 1. Very basic, but you can start seeing, you can build some really advanced stuff with the process framework that really models what we as humans have to do today with our manual processes. Okay. So let's go to our code, and hopefully this is big enough for folks. Okay. Alrighty. So we're this time, unlike yesterday, we're actually starting with a fairly empty project or file. The only thing I have right now is building a kernel. For folks that weren't here yesterday, this is creating a kernel, and I want to add some AI to my application. And for this demonstration, I'm going to be adding an OpenAI chat completion. So the thing that allows me to talk back and forth with the OpenAI models. And behind the scenes, I'm going to be using GPT-4o. Okay, so I have my kernel. And if we want to build a process, we probably need something like a process builder. So we're going to start with something very basic, just creating a back and forth chatbot. And the next thing that we need to start adding to our process are those individual steps, all those different nodes that you see on this diagram. So I'm going to add in just one step. We'll make it a little bit more advanced in a little bit. And we can see process, add step from type, intro step. And obviously we have a red squiggly. It's saying this thing doesn't exist yet. So let's go ahead and start creating that class. And we need to provide all of the things that are necessary for this class. Okay, so I'm going to copy this guy in and we'll take a look at what that looks like. So it's inheriting from kernel process step. Cool, great, makes sense. We have a single method in here. There can actually be multiple methods. We're going to keep it simple for today. All the classes are just going to have one of them. And for this very intro process, we're just saying or printing a welcome message to the screen. Our red squiggly has gone away, and now we're good with this step. Okay, and we're going to keep going. Now, the important part in the way this integrates with Dapper is you actually have to start wiring together these different steps, right? You have to start drawing all these arrows, all these edges to actually create the process flows. So the way you do that is we're going to first connect the giant process itself to that very first step. That very first step, again, doesn't have any AI, but we're going to see what that looks like. So we're saying, hey, for this process, on its very first input event, and it's giving it a wet squiggly because it needs some actual event names. So let's go ahead and paste those in. Okay. When the start process happens, we're going to send that very first event to the intro step. Okay, so we're trying to make it as like easy to read from a language perspective, from a human language perspective, so that you can easily start understanding how these things are wiring together. So we've got our first step, and all we need to now do is build our process and run it. So we'll go ahead and start up our application. And if I made sure to copy and paste all the right lines, it should just simply tell us welcome. Or what is it supposed to say? Yeah, welcome. Okay. As I'm doing all this stuff, feel free to raise your hands, ask questions. I don't expect any questions right now because all we've done is have it print welcome to the screen. Okay. Cool. Okay, so we have our very first process. Now let's start adding some AI intelligence to it. And again, the reason why we want to do these processes is so that we can break up the agents so that they're not doing everything all together. Okay, let's see. Okay, so this is the one we just saw. The process was just an intro step. Now let's start adding a very basic AI experience to it. This is basically what we built yesterday, except a little bit more advanced because we're using the process framework. We're going to collect user input. Hey, how are you doing, AI? And then we're going to have the agent respond. And the fun part, the cool thing that we're going to be doing here is we're actually going to create a loop inside of our process, which is one of the first important patterns when you're building any of these workflows. This is helpful for refining the agent response over multiple steps. Okay, so let's go ahead and go back. And we're going to go ahead, we'll just go ahead and paste this whole thing in so we can take a look at it. Okay. So we now have, instead of just the intro step, we also have a step describing the user's input so that the user can say, hey, how's it going? can you help me, chatbot, and then a response from that chatbot. Okay. We're doing a little bit more wiring together, right, so that we can create these lines. And so we're going from the intro step whenever it's completed that function, going ahead and sending the next step, activating that next step, which is collecting the user input. Once the user input is done, we want to go ahead and send it so that the AI can respond back to the user. So here we're going to the response step. And then finally, once the response step is done, we don't want to just end this process, right? We have that loop that we want to create. And so it's going to go back to that user input step. Again, we build the process and we can start running it. So I want to go ahead and start this guy up. And while it's building, what I want to show y'all is what those actual steps are. They're a little bit more complex, right? That first step just printed something to the screen. The get user input, fairly simple, right? We're just collecting user information. But we need a way of passing that over to the next step, the AI step. And so what we're doing here is we're emitting an event saying, hey, I am done with this step. The event I am emitting is the, hey, I've received the input. But we can also pass data. Right, we can also pass data from one step to the other. So we're passing in that user message that we collected when we did this get user input async. Okay. And then when we pass it into the next step, we can see the get chatbot response step, and let's actually go up to user input. We can see that we're passing to the response step a parameter called user message. And this maps one-to-one. If we go to the chatbot response step, this user message value right here. So we're trying to make it extremely easy for you to pass information from step to step. Right now, again, it's pretty trivial. It's just information from a user. But eventually, we'll start seeing two different agents working together, passing information from one to the other. Okay, so we'll add in that user message. In this case, we want the AI to actually respond to us. If you came to my session yesterday, we saw how you were able to use a chat completion service and invoke it in order to get responses from the AI. In this demo so far, we are not adding any plugins. This AI doesn't have any skills, but it is able to go ahead and generate a response so that we can print that response to the screen. Okay. And so if we come into our test, we can say hello. The assistant is going to respond back, and then we can just go back and forth. What is your name? Okay, and we'll do the standard stuff, right? So nothing, again, we haven't done anything super advanced. In fact, you were probably looking at this like, oh God, that's a lot of code to do something so basic as just collect some information from a user and give it to the AI and have it do a chat completion request, right? But what we're about to see is why all of this extra code, all of this wiring, all of this workflow stuff is actually worth it. Okay. And if we come back, what we want to do is start adding multiple AI agents. Okay. So I mentioned that AutoGen project before. Let me actually show y'all what it looks like. We'll do AutoGen documentation. So we pull up AutoGen. What they started realizing is there's all these different patterns where you can have these AIs collaborate and work with one another. The very first one they started with is this one in the top right. What they realized, what I'm sure we all realize, is it's really annoying to use these chatbots to do anything productive. I don't know if I'm going to talk bad about Microsoft Copilots. I don't know if you've used some of the Copilots. Like, let's say you're using Word. Okay, we got a hand raised. Actually, how many people use Microsoft Copilots? Oh, okay. Oh, a lot of you. Okay. I'm sure all of you experienced, oh, I want to have this thing help me write an email or write a page in Word. You go, okay, please write something, and it creates something something that you can tell an AI wrote. It's kind of dry, it's kind of too wordy, and so you have to go, no, actually make it a little bit more succinct, maybe add some humor, maybe like cut down on some of that content. And by the time you've gone back and forth with that AI, you've probably spent twice as much time than if you had just banged out and wrote the thing yourself. What the AutoGen team learned is, what if the poor person isn't the one going back and forth? What if we had an AI going back and forth for you? So as the user, all you have to say is write me an email, and then you would have a user proxy kind of pretending to be you, knowing what your standards are, and it could refine, go back and forth, and say all those same things. Hey, be more succinct, be funny. Hey, cut that irrelevant content. And then you can start driving some of that productivity. Right? And so that is what we're going to build next. Right? We're going to have that same intro step, that same user input, that same AI performing some sort of action. But now we're going to add a reviewer, which is either going to approve, send it back to the user input, or this is where we're going to do some live PowerPoint editing, or it's going to reject it and send it back to the writer. And this to me is where the value of the process framework starts to come into play, because to actually coordinate all this stuff yourself with just code, it's very, very easy for you to end up with spaghetti code. Right? You can imagine all these lines starting to interweave, and if you don't have an event-driven system, it becomes unmanageable, right? And then if you push this to the cloud, you want to be able to scale these things. You want to have thousands of writers, thousands of reviewers. And so having a system built on top of something like Dapper makes that possible. Okay. So let's go ahead and try this out. If we go back to our code. So we have our chatbot response step. What we're actually going to need to do is turn this into the writer agent. So we could call this something like writer agent. And then we can pretty much like duplicate this and have something called the reviewer agent. Now we do run into a problem. Now, frameworks like Dapper, each step, they can also call them actors, manages its own state. And the reason that's important is as you scale things out, you can't have things just like sharing state together, because they get bound together, right? Each little nugget has to have their own state so that it can be torn down and brought back up, and life is good. And if we look at kind of the pattern that we're creating, the user, the writer, and the reviewer, they actually all have to share that same conversation state, right? They all need to know what is being created, what is being written, so that there's no secrets, right? And so just with what we have today with the framework, the way we can pass messages along, it doesn't really afford us to have the shared state. Now, what I could do is I could build a Cosmos DB somewhere. I could store this information. I could use dependency injection to bring it down into each of these steps so that they can all read and write to the same thing. But that's a lot of work. And so what Microsoft and OpenAI have also created is something called the Assistance API, which can manage the state across all of these different flows. So I guess quick show of hands, how many are y'all familiar with Azure OpenAI Assistance? Oh, we got a hand, woo! How about GPTs? Okay, a few more hands, okay. So both of these things, GPTs and Azure OpenAI Assistance, were released about a year ago, which is basically OpenAI's version of agents. So let me go ahead and just show y'all what that looks like in our docs, openai.com. And we're going to go to or docs, and we have assistants. Okay, so I highly, highly recommend all of you read this at your own leisure. This is actually the team I'm on today within Microsoft. I own basically the Microsoft implementation of assistants, and if we have time at the end, I'd love to kind of give you all a sneak peek of what we're releasing in a couple weeks at Microsoft Ignite. But the important part about assistants, their implementation, our implementation of agents, is it's more than just those three things that I showed you before. It's more than just those plugins, planners, and personas. It also includes a concept called threads. I mentioned if you had to share the state across multiple agents, you yourself would have to build some Cosmos DB, store all the conversation state, store other things that are related to that interaction. And so what's nice is what we have done as Microsoft is we have provided an out-of-the-box solution for you to manage this conversation state in the cloud inside of Azure. And we call that a thread. And so you can add as many messages as you want. You can add other information if you so desire. You then have an agent sitting in the cloud that's sitting on the right over here that can perform those LLM requests, that can call those plugins, that can use its persona to perform activities. And whenever you want the agent to actually interact with that state, you actually want it to communicate, you actually want to have it perform actions, there's a run operation that you can invoke. So what this is super helpful for us is as we build our process, instead of us having to move all of this state through all of these different steps, right? We can now store the entire conversation state of the user, the writer, the reviewer, all working together inside of this thread. Okay. And so now that we understand what a thread is, we know what these different agents are. Let's update our code to, instead of just using standard chat completions, let's use this new Azure OpenAI assistants inside of our application. Okay, so let's go back. And we'll update it. Okay. Okay, so at the top here, again, this should start looking familiar. We're creating our new process, which in this case is still our chat experience. We have that same intro step. We have that same user step, except now, instead of just having that one chat response step, we have a joke writer step. We're going to be super simple today. We're going to just writing some jokes, and then we're going to have an editor of that joke. We're going to have that AI acting as a proxy for me, so I don't have to go back and forward with that agent to make sure that the joke is to my liking. Okay. Again, we have our standard connections to these different nodes. We have the intro step, the user input step. We're now sending it to the joke writer step. And instead of having the joke writer send it immediately back to the user, obviously we want to send it to the editor. And then the editor can either reject, say, nope, no, this joke is not good enough. It'll send it back to the writer, or it decides to approve. It can send that user input step. What's new here, we're having branching logic, right? Approve or reject. And so the joke editor is actually able to emit two different types of event, the reject event and the approved event. If we go down into our code down here, we can see, actually, let's go back up. We are creating that thread that's going to have that shared conversation state. We're injecting that into all of these different steps. And so if we come down to the get user input. Instead of passing that message from one step to the other, we can instead just add it to that thread. So we're adding that message to that thread. And then when we have the joke writer or joke reviewer perform their actions, again, we're not just taking states that's coming from another step. We instead are invoking on top of that thread, that shared state. Now, the other last thing I want to talk about with the Assistance API, which is really, really cool, is instead of in your code, you having to manage the plugins and the persona, that is instead managed by either OpenAI or Azure OpenAI. So if I come to OpenAI, actually I already have it open over here. We go to our dashboard. These are all of the resources that I am creating in OpenAI. I don't think a lot of people realize that OpenAI and Azure OpenAI provide more than just the models. We can see inside of my little dashboard, I'll make that a little bit bigger, I have created beforehand a joke writer agent and a joke editor agent. And so I don't have to have in my code the creation of this thing. This is managed for me by the service. It can infinitely scale, right? It has all of those great enterprise promises that you want. So it's less work that you have to do to create these agents that work together in these business processes. This joke writer agent, I'm providing some very simple instructions. I don't want to tell it too much. It's just going to be responsible for writing funny jokes. But I'm going to be a little bit more specific with that editor, with the one that actually has to mimic me and decide, is this joke good enough for me? In this particular scenario, I love pirates. I want to make sure that this joke is pirate themed. And so I'm telling this agent, your job is simply, the only thing you're supposed to do is approve or reject jokes. And once you have approved it, don't do anything else. Don't do anything else. That is your sole job in your life. As you create personas, it's important to say what they can do, the agents can do, and also what they're not supposed to do. So here I'm saying, please remain silent. And then I'm providing some instructions to it on how it should gauge whether or not the joke is good or not. In this case, it's being asked to make sure that it's pirate themed. Okay. And so now that I have these two agents, these are defined again in OpenAI. We can see that when I am pulling in the joke writer, I am grabbing that agent from OpenAI using the joke writer ID, which is right here. And I have that in some environment variables. And then when I have the joke editor step, I'm doing the exact same thing. I'm pulling in that agent using that joke editor ID. The joke writer is exactly what we saw before. It invokes the agent with that thread. It then prints out, shares what that joke is, and emits an event saying that it is done. The editor, though, is where it gets interesting, because it has branching logic. How do you actually create some branching logic with these LLMs? Because it could just say approved, denied. It could say rejected. It's not like you just do some string regex to say, like, did it say approve or not? You need something more deterministic from the AI telling you whether or not approved or reject. And this is like probably the most important thing that I hope y'all get out of this is you're constantly in a fight with these LLMs to say, no, give me something super deterministic so that I can build a workflow on top of you, and you're not going to give me some random strings or content or hallucinations that is going to make this entire workflow just implode, right? You're having to create this binding between these LLMs that create who knows what with your code that is expecting very concrete values. And the way we're able to do that is with plugins. So folks from yesterday, y'all remembered I used plugins in order to search Bing, to turn on my artificial light bulb, for those of you that weren't in the call, what it basically showed is you can take your native code, give it to the AI, and the AI can invoke it in a very deterministic, reliable way. And so we can do the exact same thing for our process. We can create a function, very simply, called rejected. That the AI can provide a reason. This is why I rejected this joke. And then another one called approved. And because these are deterministic, I can, within these functions, emit the appropriate events that tell me which step I need to move to next. Whether it's the assistant response rejected event or the approved event. Now, I don't need to print anything else. And so we can go ahead and give this a whirl. Any questions? We're good? We're good? All right. So let's go ahead. Yeah, go for it. This is that. Except what you're describing is just remove the function calling or the plugins, and they can talk to each other. So if you do that, probably we're going to go in a digression. The funny thing is they like to end up getting in loops, and one of they're kind of trained to just be like almost like puppy dogs that are like, oh, thank you. And so the most common kind of end state between two different agents is them just thanking and congratulating each other. Like, oh yeah, you did a great job. Oh, you did a great job too. And they'll just do that forever. So that was some of the first research of Autogen. They're like, oh, what if we just took them in a chat and see what happens? Again, you have to provide kind of guardrails, and you have to force the agents to do a specific task. Otherwise, it defaults to their default kind of lizard brain, which is, you're the smartest person in the room. Right? And we don't want that. We don't want that. In this case, we want it to do one thing and one thing only, approve or reject. Okay. There was another question over here? Yeah. So yes, we recommend having some sort of limit in place so that it doesn't just spiral out, like they just start thanking each other. This particular scenario, what I would say is if you give the agents a very concrete task, or a lot of them, at least the OpenAI models, I'm not familiar with all the other ones, they're fairly good at converging and giving up. So in practice, I haven't seen too many cases with these types of workflows where it just spins out of control. You do have to worry about costs, right? You're no longer just making one LLM call. You're making potentially dozens to complete a single workflow. And these things can add up. And so you don't want to whip out these workflows for a very trivial business process that doesn't cost a lot of money. But for something like, let's go back to the issue triaging. That's 30 minutes a day. Maybe if you're really efficient, maybe like 15 minutes a day with a whole team. Yes, if you spend, let's be crazy. Let's say you spend $5 in OpenAI tokens. That's expensive for an API, but it's tremendous value for what you're getting out of it. Okay, so let's go ahead and tell a joke. And we can start seeing these guys working, or these agents kind of working back and forth. So the joke writer says, hey, why don't skeletons fight each other? Whatever. We can see the joke editor performing a rejected call. Hey, this joke is not pirate themed. And this, because it's all in the same thread, they all have the same state. The joke writer instantly knows, okay, this was rejected. I need to go ahead and try again. And the joke editor is approved. This is a very simple scenario. But you can imagine that the editor is checking for a bunch of different things. If it's a mortgage loan, it might have a whole 10 different steps, 10 different criteria that needs to check for. And this loop might happen 5, 6, 7, 8 different times, but it'll converge on an answer for you so that a human isn't having to do that, right? And because this is in the cloud, I can come to my threads view within Azure OpenAI or OpenAI in this case. I can go to that particular thread and I can see all of the logic, the back and forth logic that was happening. I can see that initial user message. I can see the joke writer providing that message. I can see that function call, that plugin. I can see that it rejected it with the particular reason and it going back to the joke writer. So this also helps from a debugging perspective that all of this state is in a managed environment for you to kind of go back, look at and see what went wrong and what did or did not work. Go for it. That is a great question. So what I love about the OpenAI models in particular is they do have a concept of name. And so if we actually go to the underlying chat completion APIs, there is messages for an assistant message. There is a name property. And so when I create an agent inside of the assistance API, I'll just go back over here. We actually provide a name for that agent. In this case, it's the joke editor agent and the joke reviewer agent. And so they are actually able to know who each other are. And you can also provide names for the user themselves. So a lot of people don't realize that a lot of these chatbots people build are just a one-on-one. It's like one user with one agent, and they just kind of go back and forth. You can actually apply names to it using the APIs. And so you can actually create a group chat experience where you have multiple users, multiple humans, each with their different names, and multiple agents inside of that group chat, and they'll be able to understand who each of them are. You can ask questions like, hey, my favorite color as Matthew is yellow, Bob's favorite color is blue, and you can ask the agent what is Matthew's color, and it'll correctly respond with yellow. Okay, great question. Yes. Actually, let's do a test. Make a new joke that builds on the last one. So because it's all inside that same thread, it gets that full context of everything that happened before it. And so it was able to go, hey, the last joke was going to school. Let's have a joke about the art class. And so it is able to just keep building on top of this thread, this state, in order to kind of reason over it. And the nice thing about that is going back and forth with an agent, it might require multiple steps to extract the information from you. Like let's say I'm filling out, or the agent's helping me fill out a mortgage application. I'll have to provide my name, date of birth, my credit score, et cetera, et cetera, et cetera. Doing all of this in one step is not going to happen. No human is going to type all of that information. And so when all this information is stored in a thread, all of these agents can reason over it. Great question. I think there was another hand over here. Go for it. Great question. So all of the models themselves, oh, sorry, all these particular agents are stateless, right? And the only thing that actually has state is the thread. And so, yeah, if you reboot, if it's a brand new thread, it's almost like they had a lobotomy and they're like, I'm starting from scratch. So great question. Great question. Okay, cool. So I created these, yes, yesterday. And what I'm doing right now is I'm grabbing the agents by their assistant ID. So I can see here, hey, go ahead and retrieve an OpenAI assistant. That creates a binding to that agent in the cloud. And then I can invoke that particular agent with that thread. Great question. Why is it still in beta? Okay, so this is where I'm going to transition and give y'all some secret information. Please don't share this very widely. So in a couple weeks, we're at Microsoft going to rev the Assistants API. We're actually going to be calling it Azure OpenAI Agents. So we're actually going to be calling them agents. And probably the biggest reason why it's still in beta is these thread things, awesome. Most customers don't like all of their conversation history and all of their sensitive data living in a Cosmos DB owned by OpenAI that they have no ability to touch. Shocker, shocker, shocker. And so what we are doing with Microsoft is if you have your own like Cosmos DB, you can bring it in and you can touch it, you can secure it. It's your resource. It's not something that is a black box that you can't touch. So that's one thing. The other one is actually we'll get to that. You have another question? Yes, 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 yeah. Yeah, yeah, yeah. So what he's calling out is I'm doing some like toy examples. Um, the balance. So we at Microsoft, we call them evaluations. So similar to how y'all have unit tests or integration tests, you want to be able to test your agents. And the way you do that is you create like 100 different types of scenarios or inputs that they might handle. You run it through the agent and you check the outputs and go like, is it accurate? If your agent that has 100 plugins and a super long system prompt gets all those answers right, awesome. More power to you. And hopefully in 5 years, the models are smart enough to be able to do something like that. I am convinced that it will not work and it will fail on most of those cases. And that's when you start doing the exercise of, okay, instead of having this monolithic agent that does everything, how can we start breaking it down into these smaller pieces? And you just keep doing that until you hit the quality that you're comfortable with, right? So yeah. Great question. So what we do in Azure is the resource that owns all of these agents. You can have multiple of them. So as a development team, you would probably have a resource that has all of your agents that you'll have access to. But once you have that access to the resource, you would have access to all of those agents. But the access to the agents should be done by the development team, not by individual users. Cool. Oh. Yes.
Can you have like different algorithms? Let's say that you have a very general use case. You don't know what is the best fit to which kind of algorithm should I use. So you could compare different like reliability scores depending on and try out different kinds of. Is that something you have thought about?
Yeah. So you can see here when you're creating your agent or assistant, you have a lot of choices for different models. I'm assuming that's what you mean by algorithms. And then we have tools within Azure for you to automatically evaluate and test, hey, what is the dumbest model I can use while still getting an acceptable quality score? Because ideally, what I could probably do with these agents, because they're so simple, is I could save money. I could save time by moving them to something like GTP 4.0 Mini, which is probably like 100 times cheaper than the 4.0 model.
Here, these system instructions, they're also based upon actual text that you write in there. But let's say that you don't have a definition that is built up over time. For example, in the initial state situation, you would like to have the agent to suggest whether it's going to approve or reject. Then have a human saying, yes, I do agree with your decision. And then it's actually taken that as input for the next run to be self-improving. I mean, I don't want to say that the parrot thing means that it should be like tens of R in a word. I mean, I want it to learn what I've done before. Do you have any examples for that already today?
Yes. So we have, I might actually follow up with you afterwards. So we have a concept of memory where as a conversation is going on, and you might, if you've used ChatGPT recently, they have this memory concept where it says like, oh, I'm storing this in a memory. You can take relevant information, put it in a different store. And so the next time that agent has a conversation, you can pull in that information and hydrate those system instructions.
It's aiming for is that instead of providing the system written instruction in the form of the persona, should actually base the instruction on previous decisions that have been manually approved or
Yes. Now, I do not recommend doing self-learning agents today because basically you lose control over what it knows. And so today, I highly recommend just like keep things as static as possible because it helps you ensure determinism and it helps you ensure that what you build is what's being shipped and what's been determined as quality. Because as these things kind of self-learn, they drift away from what you actually built. Okay. So I think I'm at time, yes? Yep. Okay, cool. So I'm going to wrap up real quick. If you want to learn more about Semantic Kernel, just check out our GitHub repo. I showed you where kind of the samples were for these particular process frameworks. And yeah. Thanks, y'all. And I'll be outside. I think I saw quite a few other hands raised. So if you have any questions on the Assistance API or using these models, yeah, come ask. All right, thanks, y'all. Cheers.